Awesome. Okay, hi officially, everyone. Welcome to the December volunteer meeting. Today we have the fabulous Michael Kirk, who's going to talk to us about some updates post Eclipse and post AGU and post some other things. And then we also have the five or six people who are going to share. So first, we're going to have Laura give us some updates, then we'll do sharing, and then we'll hear from Michael Kirk. Take it away, Laura.
Okay, first, can you tell me, does it say Sonoma State to you all? Like going the right way? Okay, good. It's backwards for me. That's fine. All right, welcome to another Eclipse Megamovie episode. That's what we're calling these, right? I just wanted to give a quick update. We've been working, we just closed our Kaggle competition of machine learning coders, Python coders, and we're about to send an email to the winners and make sure they're in the US so we can send them prizes. If not, there'll be other winners as well. Um, and so that's exciting. We had some really great participation there. I wanted to see overview. We had 125 entrants, 31 participants, 29 teams, and 332 submissions. That's pretty good for our little pilot test machine learning effort. I feel very happy about that. The other thing we're doing is taking all the comments that you made about your metadata, and we are fixing the metadata on the images. We have a student working on that here at Sonoma State University, and we'll be then quality controlling, checking that. We also had a bunch of students here at Sonoma State take your images from 2024 Eclipse and um, do a machine learning effort on rotation of the eclipses of the different exposures since even though many of you had a tracking there, so you had your tracking mount, most of you, but then so it's centered at least for all the images, but there was still some rotation that needs to be done to align over time over that 4 minutes. And so we labeled some of the rotation for our students, and now they rotated it, and Troy went and saw that last week. That was a research project in a kind of a research class led by Professor Gurman Gill here at Sonoma State University. Also, we had a student over the summer. Juan had a student that he worked with who worked on also some rotation code, but also making your pictures fit on a kind of a polar alignment. We showed that a couple months ago. And she presented at the American Geophysical Union on her work and about the project with Juan. He was there supporting her. And so I was there later in the week, but talked to Juan and he said it was a really great presentation and people came by. Um, and then Juan, our goal is to have the movie done by March so it can go in a planetarium show and we can show you all. So those are all our big updates for you. I have one more thing I wanted to share with you because I remembered that we have this great, not we, but a colleague of mine created this amazing app and I wanted to show it show it real quickly. So I'm going to actually share my screen on my phone, which is a different login. Um, so I think, Dar, we can remove the spotlight on me and find the other me. Um, and then I'm going to do a share on there. I'm going to share my screen. Okay, I think it's working. Okay, now how do I? Okay, is it sharing? Oh, look at that. You can see my. Okay, I'm not doing so well in Duolingo. I've been busy. So it's this Sun Science. And what I love about this is it has the sun observatory and you can look at live views of the sun and you have the scroller so you can pick like the sunspots. Oh, can I get rid of this? I don't know. So the sunspots, and then you can look at how it looks like in extreme ultraviolet. And you can go, ooh, weird. What the sunspots are kind of different than what I see. So, anyways, I love this tool. And then there's also all these activities you can do with, well, you can learn about all this stuff. And then if you go to DIY home, then there's activities. You can make a sun cookie with your young ones in your life. Okay, that's it. That's what I wanted to share. So let's see if I can stop sharing now. Hmm, stop share. I did it. Now I can leave the meeting. Okay, that's all I have to show.
Awesome. Thank you, Laura.
Mhm.
So, without further ado, we will jump into our 5 minute photograph story share, beginning with cause. I remembered because I forgot the first time. So, let me give you co host permission. There you are, cause
Hey,
and Heather.
let's see. Oh, share,
Awesome. And
in
your
my screen
timer.
now.
Yes, we can see your picture.
Okay. Yeah, we have some aurora northern lights. Actually a couple times, and the like huge one was twice, which was May 11th and October 11th. And this one is first time we tried a time lapse. Heather had the camera set it up and then sitting there. She just keep clicking hundreds
On the
of
same
hundreds
spot.
times, and
Yeah.
then after that try to put together to the movie. And but it's still a couple hundred. Should be couple thousand, but just like couple hundred. So it's a 18-second short video, but uh yeah, it was nicely changing. When we alive, there was like a peak time. So it was so bright and it faded out and quiet. Another came out and it's small dancing around. So, and then now we see the arch at the end. So it was quite a unique night.
Wow.
We were out from 7 p.m. until midnight. So we saw about three different peaks of the curtains happening. And then
That's
we had
awesome.
the Star Arch for quite a most of the chunk of time we were there actually.
Yeah.
And this is when we
So yeah.
arrived.
Yeah, this is the more picture wise. And yeah, it's like more greenish in the bottom we see this time. So it's kind of like very different. And we saw the arc, I think.
Star Arch, yeah.
And we tried it some there was a full moon at the day, so waiting for this is kind of like an interesting one. So this one had the arc in the top and the bottom tiny bit or northern lights there. So one picture, two different things we could see it at the same time. So that was kind of like really cool time.
What state are you
It's
all in?
in Arizona, so it's about an
October 11th.
hour north of Phoenix.
Yeah. And other interesting one is not the big screen, but tiny bit in aura or something. It looks like a fire there. I think it keeps moving. It looks like a storm. So it's kind of like I don't know. Is it kind of like partial or northern lights or something different? Things I couldn't find any answer, but yeah, some of the unique things go in the pictures. And after moon set, we finally see the Milky Way. So tried it to see the arc and Milky Way. And after tried a bunch of things, and then we finally see the some of the kind of like okay. We don't have the tracker, so we just best, like nice time, not too short, not too long, and finally caught in some of the part of the arc and Milky Way. So
because the other challenge we had was trying to get as far away from the city lights as well from Phoenix, which is the other big challenge we had.
other pictures are obviously we are Eclipse. So this is the or Eclipse picture from the that was
April 8th.
April 8th. Yeah.
Yeah.
So we flew to the Cleveland, Ohio. It's kind of like a little bit gambling. We were discussing where should go, Texas or different place, and we thought more people going to the Texas. So we decided to the different place. And then actually Cleveland was rain in the morning, but after that, all the sky clear out. So we could see the really clear sky and then caught in a really nice in Corona at the end. And since then, since we joined this project, we are more into stargazing or more sky, some interesting pictures. So this is another one, May 10th or 11th, different aura, not that strong than October's one, but we could see it. And yeah, that was first time we saw it, aura. Even if Heather bought the ticket to the Alaska earlier this year to try to see it, and then she couldn't
see it. Yeah. Yeah.
We are also a member of the Civil Air Patrol, and then as an educator member, and we had the like a 1 hour flight program, and we flew around the Phoenix area, and then we noticed that we are flying over the like Northern Light seeing spot. So actually, there's like a little bit off the highway. There's a few parking spots. There's like a middle of the nowhere, and actually top of the peak flat area. So this is the perfect spot we usually go, and I like see it above the sky. Like, yeah, that's why we could see it well. It's like pretty much flat and then no much trees and then like yeah, flat mesa area. So it's cool to see it in the different views.
Yeah, that's super cool.
Yeah. And then we start having more stargazing, and this is a zoom up of the Milky Way. We went to Hawaii for a little bit vacation in the summertime, and Milky Way is kind of like a season in the summer. So
we went at Mauna Kea up to 9,000 feet. And then we were there, well, up to midnight, where apparently they have like you're well away from the city lights. I mean, you're over 2 hours away from the city lights, so it's definitely a perfect spot to go and
yeah,
get
we enjoy the 90s and in the like beach, and then we climb up 9,000 feet is like a frozen cold, like a 30 or 40s.
Jacket,
but
yeah.
That was like actually it's rewarding on the view. So after I noticed that I have the like a fixed f1.5 lens, but that was 2x zoom already, and it's fixed lens, so I switched to the different lens and like a little bit zoom out to catch more wider and then finally see more better quality Milky Way pictures. So, and then last day of the Hawaii, we have a more adventure. Volcano erupt. Only 12 hours, but just before heading out to the airport, it was erupted. So we headed to the volcano before the airport. And then you can see the tiny helicopter. There's a USGS researchers actually flying into the volcano active eruption area. And then like they drop off and then like a couple hours later, they pick it up. So like it was interesting timing.
On my last day, we were there, and then we saw.
Yeah, we saw that different one. This is the like halo. Yeah, it's kind of like Arizona. It's kind of rare to see it. And like one day we played the pickleball in the park, and then everybody stopped playing. Like, why you're not focused on the playing? And they say, oh, there's something weird on the sky. So like, oh, and then like everybody started taking a picture, and that was great halo. And then a few days later, we had the moon halo as well. But a lot of people say after seeing the halo, usually weather goes bad. And like we have enjoyed the 80s nice warm weather in here, but now it's down to the high 70s. So it's getting cooler. So yeah. And last one is like short video. We also had unique place. We are close enough to the California's rocket launch sometimes. So if we are lucky enough, we could see the rocket launch from the front door.
SpaceX ones, what's the other one called?
Firefly.
Firefly. Yeah, the Firefly is another one we've seen.
But we noticed that because we are 300-400 miles away from the rocket launch spot, and they're shooting out to the Mexico Gulf, so it's pretty much far away, and we could see this tail only specific timing soon after the sunset. That's only the time we tried to see in the midnight or like 2 hours later after the sunset, but this tail actually reflecting from the sun, maybe still shining in Hawaii. That was hitting on the high air. That's how we see it. But like if too late, the sun is already gone, so couldn't see any tails at all. So it's kind of like a unique experience. We had it and then learned from it. So yeah, that's pretty much we're experiencing a lot of things since after we start joining this great
Yeah.
sessions.
Very cool. Thank you, Kaz and Heather both. I gave you more time, obviously, because you're sharing for both of you. Wow. Those were some pretty, and the shot of the rocket, for the first time I saw it when it passed by very quickly, I was like, no way that's the meteor or something. So, okay, good. I'm glad it wasn't, because that would have been a crazy shot.
Oh yeah,
There's the
like local
timer.
news, like
Yeah.
people saying like there's a huge meteor. No, that's okay.
All right. Next in the queue, we have Richard. And then after Richard is Spencer. If you're here, I see Spencer. Okay, Richard, let me give you permission. You have 5 minutes. Take it away, Richard. You are muted.
Yeah, there.
There
Okay.
you are.
Now I've never tried to share before on Zoom, so this may not work. Uh, okay. Can you see the image?
Not yet. You might have to click on another. You have to click twice to make it share. Maybe three times.
Share.
You click on share, then you
Okay.
click on what you want to share.
Okay. Okay. And here we go, I guess. Okay. Didn't get to Mexico. We were supposed to go to Torreon, but my passport was damaged and the Mexicans wouldn't let me in, which all told cost us big bucks between the trips and the travel. Anyhow, so I put together a selection of pictures from previous eclipses we've been at. This was 2015 on Svalbard archipelago on the island of Spitsbergen in the Advent Valley. This was the first diamond ring. Now, it was right at equinox, so the sun was only 12 degrees above the horizon. Our site was 78 degrees north. It was minus 20 Celsius. Okay, and here's a composite showing some of the prominences and the corona itself. Also some Svalbard. And this is the view my wife caught with her camera, short lens. This is what it looked like. It was right in the notch of a hill, and we were far enough away or far enough north. We were actually north of the auroral circle, and had the gods smiled on us, we would have had northern lights on top of the eclipse. The gods did not smile. Okay, next one. After eclipse, you need champagne. And the press corps, of course, gathers when there's free champagne to be had. Okay, this for some reason is telling me nasty things. Okay, This was 2010 on Easter Island in July. And there are these Moai statues, and everybody carves things. And if there's a statue, someone will put eclipse glasses on it. We put some on ours. Little boy, about a year and a half old, came and kept stealing them until his grandfather pulled them away. Uh, so that was before the eclipse. And here's the first diamond ring of that, a little bit of lens flare. You can see a few of the prominences there in the coronasphere. Okay, and this was full totality. Uh, I would have liked it darker, but that was Clay's. And this one actually was from 2006 in Egypt. Um, Serious lens flare, which my wife upgraded a bit to make it pretty. Okay, and as I say, this is back to Easter Island post Champagne. Okay, this is at El Tambo in Chile for 2019. This was the Travel Quest group setting up. And here was totality, and on the notch down on there, that's Venus, just in the notch in the hill. We lucked out on that. It was sufficiently close. Okay, and this was second diamond ring at Tambo, I think. Okay. Also on that trip, we took a trip out to the Galapagos. This is a frigate bird chick in the rookery. Talking to Kaz and Heather, if you want really nice um, Milky Way, try the Galapagos Islands because it's absolutely dark. It's fabulous. Anyhow, so this is now going to comets. This is my shot of the recent comet. I had to boost the contrast just a little bit. Okay, this was a shot that I bought uh, of Halley's in '86 from Arizona when you could still see the tail. We went to Chile in April and the tail had pretty well dissipated. This is Hyakutake from 96 in March. No, I'm sorry. Yeah, this was March 96. And you can see it's passing the northern lights here. Hyakutake was just fabulous. Um, Here's Hale Bop the following year, and you can see Cassiopeia there. 8 days later, here's Cassiopeia. The comet had moved that far in 8 days. Okay. Now these are a couple of bought ones. This is Schumacher-Levy 9 when they first discovered it. It had passed Jupiter and just broken up. And then when the largest piece hit Jupiter and exploded, there's that one. That's my shots. Hope you enjoy them.
Wow. Well done, Richard. Those are beautiful.
Thanks. Thanks.
I'll
Thank you.
take this spotlight off you. Great
Okay.
job with those. And great job doing it in time too.
Yeah.
Next up we have Spencer. Let me get you set up with permissions.
There.
And we'll get you the spotlight. Take it away, Spencer.
Can you hear me?
I
Yep.
can hear you.
Okay, let's go to share. What am I sharing? I'm sharing
I think the first one is the option to share your entire desktop, and that'll do the trick.
This guy? Um,
Yeah.
can you see that?
Yes, I can.
Okay, that's October 14th from my youngest son's sixth floor balcony. That's the comet. And that's a close-up of it.
Oh, I lied. What we can see looks to be like your photo album or the
Oh,
folder that you've
wait
got
a minute.
photos in.
Wait a minute. Let me back up then.
You might have to click on the share and do a share other or share next or something. There's a way to choose another thing to share.
Get out of this. Get out of this.
Do you have more than one screen?
Yeah, I got two screens.
Yeah, you might so there's a tab when you go to that share button. If you hit share again, you can click on the screen tab and then choose which screen to share.
It says I'm sharing the screen that I want to, but I don't see. Uh, can you knock me out of
Sure.
sharing? Because I don't have the button anymore. There we go. Okay.
That's my desktop, everybody. It's pretty.
I want to go to screen 2.
Mm-hmm.
Is that it?
Yes, give that a try. If you shared one before, try two this time.
Is that it? Can you
Yes, I
see?
see a picture, a big picture.
Of Comet, right?
Yeah. All right. Resetting
All right.
timer.
All right. That's the first one I wanted to do. That one is from my uh, youngest son's sixth floor balcony looking west. That's October 14. That's a closer shot of it. These both were stacks of 10 images, each about 2 seconds per image. It's like 1600 ISO. And then we go to Eclipse. This was my setup in Ennis, Texas. Um, had a GM8 Losmandy mount with two cameras on it, and all these guys were helping me. And you always get the press whenever you do things like this. But I got some good shots. I hope some of them show up in the movie. Um, and in this one, you can see Earthshine around the surface of the moon. And that's the one that I liked so much. And if I go back to here, you know, if you have press around, they'll always come over and talk to you. If you have the biggest mount in town, you're the only one they come to. So you start you start doing TV stuff and they just run you crazy. And then you get CBS and they just run you crazy. And then the press is helping you set up. And that's my wife. She loves to watch the people. And they help you set up and they still come around, everybody, and they won't leave you alone. You're trying to shoot pictures, they won't leave you alone. But that's the size of it. And where do I get out of share? Um,
I can knock you out again.
okay.
Welcome back to my desktop.
That was less than 5 minutes, wasn't it?
It was, yeah, that was 3 minutes actually. So you've got
I,
two
wa-
minutes. You want to do anything with it?
I wanted to rush through it. Nah,
No, you did great.
that's good.
And so I was going to say this in chat, but I'll just say it now anyway. If you have either like URL links or just copies of the video interviews that you did, any of you, if you were interviewed by local news, send them my way. I'll collect them and we'll get them on our website and we'll send them out in newsletters and stuff.
Okay.
Awesome. Wow. Thank you, Mr. TV Star. I did not realize we had
They won't leave you alone.
All right, next up is Tom. I did not put Saxton after the name Tom, so I'm assuming it's not Tom Saxton. I think I see yes, it is you. All right,
Okay.
Tom, you have co-host. We'll get you a spotlight. All right.
Uh,
And I don't see Jerry, so Tom, you might be our last one today. Oh, Tom and Jerry. I didn't, there is actually a Jerry Dobeck on the list. That wasn't a cartoon joke. Anyway,
Okay, that did not give me what I wanted. Let's
do you
try.
want to share a different screen or?
That's not working. Mhm. Well, what I would like to share is that.
What are you trying to share?
I'm trying to share a video on my other screen.
We see a video.
You do?
I see Aurora too.
Oh, okay. Well, it is working then.
Yeah.
Yeah.
All
Oh,
right.
it might be weird because of the Zoom. So anyway, go ahead.
Okay. This is the Aurora, the last Aurora, and I took a lot of pictures. I watched it for 3 hours, and I took a picture every 30 seconds. So I got a lot of pictures, and I put them all together into a time-lapse video. I'll start that here. I hope it's running.
It
Can you
is.
see it running?
Yeah, we see it.
Yeah, this part right here, I'm looking almost straight up. It was really cool because it looked like it was radiating out in all directions from straight up. It was really, really fun to watch this part of it. But there was so much stuff going on. I had a hard time deciding, which way to point the camera. So I kind of changed the direction of that the camera's pointing a few times. And all the while this is going on, the colors and the patterns change kind of slowly. But at the same time, there was a very fast shimmer that kind of moved through all of it, and which was really interesting. But you can't see that in this time-lapse video because the shimmer was really too fast for the longer exposures that I was using to capture the images. So each image here is about, a 10-second duration. And the video itself is about 2.5 minutes long. It covers the whole 3 hours. I know that Laura has seen this already because I posted a link on Discord back when I made it. And this is a revised version. I kind of cleaned it up a little bit and kind of boosted the saturation a little bit. And Laura commented that maybe I captured some black aurora, I think she called it. Maybe she can elaborate on that a little bit.
Yeah, so there's different phases of aurora, and because the Earth rotates underneath the auroral oval, is when you go kind of towards midnight, the midnight sector, into the morning, you start to often see this diffuse aurora, and you can see black aurora in it, which are very well-defined arc-like, basically regions where there is no aurora. And so we call it black aurora. It's really the absence of aurora in a diffuse background. And it looked like some of your images might have had some of that in them.
Okay, well, that was the video, and that's really all I have to share. I didn't get any pictures of the eclipse because I was there and ready, but the weather didn't cooperate. So
For sure. Thanks, Tom. Where were you?
This is from Nebraska.
Ah, cool. Very cool. Did you submit to Aurorasaurus?
No, I'm not familiar with that.
I'll put a link in the chat. They're another citizen science or participatory science project. Aurorasaurus. Gotta spell things out in my brain. Um, and I mean, I'm sure they've been inundated with submissions with all the Aurora lately, but they take photograph and video evidence of Aurora and then they examine it. And so before geomagnetic storms, it's probably people submitting pictures of maybe just Milky Way that they see and saying like, "Is this Aurora?" And then they say, "Yes, this is Aurora." And yeah, Laura just put in the chat that their server actually went down during the May geomagnetic storms or the magnetic storms. So they would love all of you, for everyone, please submit your Aurora pictures and videos to Aurorasaurus because they do really fascinating work with it. And it is a project close to Laura's heart, as we all know. Thank you, geomagnetic storms. Okay, cool. Awesome. Thank you for sharing, Tom. Well, you
All
have like
right.
2 more minutes left. Anything you want to do with it?
No, I don't have anything else.
All right. Well, thank you for sharing. I'll do one more check for Jerry. No, Jerry. Okay. So, Michael, I think it is your turn. Let's get you co-host. Let's get you a spotlight and
Hey,
take it away.
hey everyone. So my name is Michael Kirk. I have the pleasure of being the lead of the Heliophysics Education Activation Team out of NASA Goddard Space Flight Center, a researcher, a consultant on this project. So I wanted to share with you some recent things from the American Geophysical Union. So that's what I'm going to do. Let me get my slide deck going and. Right. Are you seeing a yeah, awesome. Okay. So, I'll give you some eclipse updates. So, a lot of you have a tremendous amount of experience photographing eclipses, seeing aurora, watching the night sky. But I want to give you a little bit of perspective of some things that the scientific community is thinking about, some minor updates, and then things to look forward to coming up in the near future. Mm, mm, mm. Okay. All right. So first of all, I talked about the AGU meeting. So what is that meeting? Some of you may have been to it, but it's the American Geophysical Union Fall Meeting. This one's 2024. It took place December 9th through 13th in Washington, D.C. This year, I heard that there were nearly 30,000 attendees. So this is a minor city of scientists, both space and Earth scientists coming together in one place to share science and updates. So it's a madhouse. I saw Laura for about 15 seconds as we passed each other in the hallway and never saw her again. It's that kind of meeting where it's just it is absolutely crazy. So there's more than 100 countries represented, and it is billed itself, and I believe so. I did some research before this. It builds itself as the world's largest gathering of Earth and space scientists. I couldn't find anything to dispute that, so I'm going to go with their tagline and say that this is the world's largest gathering of Earth and space scientists. So at this meeting, there was a lot of different facets that were being shared, but one of the first ones I wanted to start with was really the impacts of the eclipse. So this is research that was done out of the University of North Texas by Gerald Knezik, and he and his team were really looking at what were the largest impacts of the eclipse, specifically talking with school children. So the survey that he did across a few different middle schools in North Texas, so this is north of Dallas, Texas, in the Denton area, he said, "What word would you use to describe this solar eclipse?" So he did a pre and post interview with these students and has been engaging for the 2017 eclipse as well as the 2024. But these are quick findings of him. Of his, most of the people refer to as cool or amazing or fun or interesting or amazing misspelled or maybe is that just lowercase? Awesome, exciting. So only 3 of the 67 responses that he got were something negative. So that means that overwhelming 96% of sixth graders thought this was a significant experience in their life. And if you know anything about middle schoolers, getting them to agree that something is neat or cool or amazing is pretty spectacular in and of itself. And so you're doing some really amazing work here by bringing the eclipse to school kids. I've talked with a few of the, I think it was high schoolers after the eclipse in Dallas, Texas, and the ones that replied negatively, as in it was okay or not that great or disappointing, they were either clouded out or they didn't actually see totality. So I think even those three descriptions of less than great probably were because they missed it. All right. So the other thing that AGU is fantastic for is sharing scientific findings and early scientific findings. Of course, the scientific findings coming out of this meeting are relatively preliminary. There's not that many months that have gone by since the eclipse, and science is long and hard. There are a few things to share. First of all, you can see the image there on the right. That is an image in an iron 10 line, so a hot corona line by the famous Mieczysław Druckmüller, who takes spectacular eclipse photographs. These are, of course, highly processed and highly stacked. So you don't be fooled that he has some amazing magic camera. But no, he's done a lot of post-processing on this, of course. But you can start to see some of these faint lines in the corona. If you go to his Eclipse website, all of the images are up, and you can take a look at them. They're stunning. Um, there was a few different groups at AGU that were presenting on capturing coronal diagnostics via imaging. And so these really fell into kind of two camps. One is understanding the magnetic fields on the sun using polarization measurements and using different temperature lines to see the different plasma layers in that corona. Polarization is really good for getting diagnostics on that light that's coming from the corona itself. And so you can really see some origins into dynamic processes, and especially as you stack them all up with Megamovie or Citizen Kate, you start to see dynamics and things changing. The other one is diagnostic coronal plasma properties and polarization and temperature data, whether you're looking at a specific line in the solar atmosphere really helps doing that. So it looks, you can get densities of the corona, electron density, temperature distribution, scattering processes. There's a lot of insight to understanding the corona using these data. Well, what's the current state of the data? This is a grab from Raphael Attier, who's a friend and a colleague of mine. This is his polarized brightness campaign. He went up to Maine, and it wasn't quite Holton, but up to mid-Maine to take this image. This is his post-processing, and you can see that he's gotten the mosaic put in there, and then the color table put in there to indicate the polarization angle of the light, so that depending on the hue that he chose in the HSV color, if you're familiar with color spaces, he's using an HSV format. The intensity and the hue of that color indicates the polarization state of the light. You can see that it is compelling. It's interesting. It's not quite finished yet because you can clearly see the mosaic pieces of it. He has some more post-processing to do, but he's running the same post-processing tools as Citizen Kate, and so when that citizen science effort really takes in all of their data, they'll be using the same materials. He's just a little ahead of the game because he's doing all of the photography and processing himself. A really neat thing, this is another Druckmüller photo, is you were able to actually see a comet during the total solar eclipse. Some of you may have been able to see it. This is a zoom in from Druckmüller's observing site. I think this one is in uh, this is in Mexico, I believe. So you can see the amazing structure of the solar corona. You can see the chromosphere and those red little blips. And then, of course, down in the lower left-hand corner, you can see there's a Comet Soho 5008. And that red flare, that red image from the comet is from a silicon line, I believe, if you're keeping track. The other interesting thing that I wanted to show you, which this image highlights, is the amazing image stacking they do in order to get these beautiful eclipse images. So you can see two dots; they're highlighted in C2 and on the bottom, C2 plus 207 seconds, C2 plus 36 seconds. That's the same star. And that is how much drift there is during the photography campaign. And so when they do this mosaicing, the amount of drift of the sun and comet in this case compared to the background field stars just during their photography campaign can be substantial. So that is where you get this image stacking. You have to be really careful. You end up, if you have a keen eye, you can see that all of their background stars are a little bit elongated because of how much stacking they're doing while they're tracking this thing. So it is non-trivial to be able to stack these images and get the beautiful post-processing. This is a slide grab that I took during a presentation, but there were a significant number of coordinated campaigns from different observatories. So this is a little slide that shows all the different observatories that were all observing simultaneously. So Mauna Loa Solar Observatory, MLSO, the K-Core instrument, and then the UComp instrument were both observing simultaneously, and you can see those fields of view sort of in purple color. On top of that, the DKIS telescope was taking a little, Daniel K. Inouye Solar Telescope was taking a little postage stamp area. In Hinode EIS, Hinode is a spacecraft, is taking spectra of that little postage stamp as well. And then ACES, which is an airborne National Science Foundation campaign, it was taking a slit spectrograph for spectra along that line of the ACES. In addition, GOES SUVI, so GOES is a weather satellite. It has an imager, an EUV imager on it. The SUVI instrument did a special off-pointing campaign to capture what was in that dashed box altogether. So you can look up the reference there if you want to see all the details of it. But it really, the observatories, both space and ground-based, both NASA and NSF and NOAA, all came together to do a coordinated campaign. So I think all of these data are still being calibrated and processed, and some of them it's available to the public now. Others are still getting released. So hopefully, the scientific community can actually use all of these different imagers to investigate whatever science campaign or science questions they're looking at. This is a little bit of a science preview of what exactly science questions were you looking at? Well, they're specifically interested in looking at coronal conditions. What are the densities of material that are there? What sort of magnetic fields thread through them? And so this is an example slide from Chad Madsen from the UComp instrument, the DKIST instrument, and the Hinode EIS instrument, all observing simultaneously. And what you see there is some density measurements of the coronal plasma from DKIST, and then some other measurements looking at the intensity and density of other species, other ions in the solar atmosphere. So doing all of those different measurements, stacking them on top of each other, you can rebuild sort of a temperature and magnetic field diagnostic for that small little area of the solar corona. That's significant. It's really hard to measure the composition of the solar corona in a consistent way. And so having these multiple observatories all observing the same place at the same time in all of these different ways really is significant to be able to get that elemental composition, the coronal diagnostics, and all of the other things that they were looking at, temperature, densities, etc. All right. Moving on to ionospheric measurements. So this is a model that was run before the eclipse, the SAMI-3 model run by Joseph Huba. So Joseph ran an ionospheric model, so this is the upper Earth's atmosphere, and modeled what the eclipse should look like in terms of impact, density impacts on the ionosphere. So what you see here is a globe, of course, and then a giant density hole as the eclipse passed over it. This is actually a movie. You can pull it up and see what that looks like as a predicted density, at least. Not only can you see a density well, but you can also see an interesting density peaks, a sort of a wake that is left after the eclipse. So it's this is what the latest models we're looking at. We're thinking of when they're looking at total electron content and the difference between what normally exists and then what the eclipse would produce. So a lot of the measurements was proving, does that actually true? Is this model actually accurate? Or are there other things going on? Are there other effects happening that we're not quite sure of? So to give you an idea of what's going on here is during the night. Oh, so we're surrounded by the ionosphere. It's a plasma, partially ionized plasma, surrounding the entire Earth. And during the night, the solar energetic particles, of course, are blocked, and a lot of solar energy is blocked, which means that the ionosphere collapses down into two layers, the F and E layers. During the daytime, though, there's enough energy coming from the sun that they split out. They actually divide out into two F layers, and the E and D layer separate from each other. So you get multiple layers of the ionosphere during the day from sun's energy, and then it all collapses back down to a couple of them at nighttime. So the natural question, the natural experiment is, okay, if we blocked the sun for a brief moment in time during the eclipse, what happens? What happens to those layers of the atmosphere? Well, you can probe that in a few different ways, and the HamSci project did it by bouncing radio waves off the ionosphere with a massive campaign. They had, I don't remember how many. I think they had over 6,000 unique participants and hundreds of thousands of connections. For this point-to-point connections where the ham radios are actually using the ionosphere to reflect the radio waves off of the bottom side of the ionosphere and be able to talk with other people on the planet. So this is a little wave diagram of the different frequencies up on the y-axis, and the epoch in hours, but where 0 is the eclipse, the total eclipse, or the peak eclipse, I guess, depending on where you are. And the color is the transmissivity at 21 megahertz. So how many receptions do they get? They had they had 1.2 million recording examples of this. And what's interesting is you can see that there's a point where the ionosphere dissipates. It collapses. It changes state right around 6,000. Yeah, right around 6,000. You have this dearth of being able to communicate. So this dearth. I'm sorry. This the y-axis is distance. So it's how far you can communicate away by bouncing off of here. So you see this power sort of dissipate in the right around the eclipse and then come back again, which means it was less effective to communicate at that distance between those 2 points during the eclipse, and then it came back again. And same with the round 2000 as well. It kind of shrunk down and then came back again. And those are due to the ionosphere changing state. And you can directly trace it back to that physical change in the atmosphere. What does it mean? Well, that's where we're still working, but you can definitely see the effect, which is the first step. This is Nathaniel Frizzell, who's leading the Hamside project. This is his own personal station where he was communicating on a whole raft of different frequencies. And between the two bars are during the eclipse, and you can see that some frequencies had a greater effect, a greater impact than others. So you can see there's a little blip at 3.5 megahertz and 7 megahertz right between the two red bars during the eclipse, where you could see some effect where it's not consistent. However, what's interesting is that there's sort of ramps down to a minimum, and then there's an interesting bump, and then it ramps back up again. So what causes that? Why is it happening? Those are all outstanding questions and things to continue to investigate. That's why it's early days. Also on the left-hand side, you can see a heat map of participants at different frequencies. And you can see just, the tremendous number of people participating and working on this. So there are, this incredible network of people working in the ham science, ham radio community doing this eclipse research. Also, ham sci isn't ending. So if you are a ham radio operator or are interested, you can join that community and help with space weather science going forward. All right. Another upper atmosphere project was the Eclipse ballooning project. So this is the nationwide eclipse ballooning project. And what they're really looking for is, again, upper atmosphere responses to the eclipse, but instead of looking at the ionosphere, they're looking at the tropopause. Tropopause is a layer in the upper atmosphere of the Earth. And the plot on the left, you can see sort of what the tropopause looks like as it goes through day night. You know, the tropopause collapses down, literally drops to a lower height overnight, and then drops back up. During the eclipse, they can observe sort of a descending phase of the tropopause. This was done by launching high altitude balloons up into the tropopause to measure it and all across the eclipse path. The other thing, of course, you can see here on the right-hand side is some gravity waves that are produced. These are atmospheric gravity waves, not the gravitational waves that you get from merging black holes, but atmospheric gravity waves. And they are able to observe both in the stratosphere and troposphere these wave propagations. Again, this is pretty low resolution data, but they were able to actually see some wave motions they were not expecting, and they're wanting to do some more analysis to look at those waves. So how does the atmosphere respond to this dark spot of the eclipse? And this will help us understand, do we know how the model works? Do we understand how the Earth works and the Earth Sun system works? So it's really proving where the gaps are in our knowledge by understanding these waves and these effects from the eclipse. So early conclusions. This was, scientifically speaking, the most observed eclipse in history. We had the most scientific observations of this eclipse than ever before, and likely for the next few eclipses too. The next eclipse, of course, is in Spain. Well, in Greenland, Iceland, and Spain in 2026, and then North Africa in 2027. And although North Africa will be a 7 minute eclipse, so spectacular, almost the longest you can get, like the physically longest eclipse you can possibly get. North Africa is hard to get to, and it doesn't have as much infrastructure as the United States does. So I think these observations will set the benchmark for the next few eclipses about the most observed eclipse to date. There were a ton of engineering designs that were validated. So this is a lot of these examples I didn't include here, but there was a kite flight. Shadia Habal put up a kite to observe eclipses and was able to prove that not only it worked, but they were able to get quality data with it. The ACES project flew high altitude Gulfstream 5 jet and was able to observe the eclipse using a Gulfstream. They had some technical difficulties and weren't able to actually get the quality of data, but they're going to fly again. And then space-based platforms, there were sounding rockets that were launched too, and were able to take data from the eclipse, launching out of both White Sands and Wallops. The scientific relevance of them still being worked on, but it validated that they could take data and actually get really quality data using these different platforms. So a lot of these projects are looking to continue their research using in future eclipses. So they're looking to fly the WB-57s from NASA, the high altitude bombers that have, well, former bombers, they're not anymore. They have a gimbaled camera on the nose that they can actually observe the eclipse. They're looking to fly those in future eclipses or upcoming ones, and then the Gulfstream, as well as sounding rockets. And so all of these, as well as the kite and high altitude balloons. So all these technology demonstrations are really important. The quick takeaway is the corona is a very dynamic and turbulent place. I probably didn't have to tell you that. You look at these hairy sun pictures, these pictures of the sun, and you can see all the dynamics. You can see all the twisted lines and loops and things moving in directions not exactly radially, where it kind of starts off one direction and curves, and that all indicates how many dynamics there are. And so getting this data at solar maximum or near solar maximum is incredibly important for understanding how twisted and dynamic the corona is. So, what to keep your eye out for soon? Probably in the next year or so. Mapping of magnetic coronal lines, magnetic fields in the corona itself. There's a lot of work on that to extrapolate magnetic field lines to be able to actually back out what the magnetism looks like in the corona that's driving a lot of these shapes. We should see some modeling efforts come together with observations soon. Also, with that, better temperature diagnostics of the near and mid corona, understanding where the magnetic field lines are opening out into space versus ones they loop back down and connect again. That will be more closely studied. And then, how does that impact the temperature of the corona? Overall, the temperature is pretty stable, but in local spots, it varies quite a lot. Um, Modeling of the state of the ionosphere is coming up. So I showed you that SAMI model where it's just sort of a blob, and that's certainly the state of the art model rolling into this eclipse. It's not going to be that way coming out because we will see things we didn't expect, and that's not captured in the model. So that will continue to refine. Atmospheric gravity waves will continue to be researched and continue to be understood. Again, looking at how does the sun affect the Earth's atmosphere in nuanced ways, not just in the day-night cycle, but in other ways. And then coming in from the some of the other citizen science efforts, reactions from the natural systems on the ground. Soundscapes was a citizen science project that has a tremendous amount of data and is working to understand how the natural world responded to the eclipses, looking to validate research that was done back at the turn of the century, back at the turn of the 1900, not the most recent century, and see what other systems respond to the eclipse. How does the natural world, how does the biosphere respond to the eclipse? So that is all I have. I will stop sharing here real quick, and I'm happy to take some questions or anything. I know I'm blew past 6 o'clock local time, so I can also end there.
Not your fault, Michael. I think if anyone has any questions, now's the time. We have a few minutes. Yes, definitely applause. Well presented, well summarized. All right, I do not see any questions. I think everyone's ready to end their day. Thank you very much, Michael, for being here and for presenting. It has been a pleasure. Thank you to everyone who shared your pictures today. Also a pleasure, and videos, pictures and videos. I'm not going to tell you the date of our next meeting because last time I tried to do that, I goofed. So you will hear from me shortly via the emails. I see you laughing at me, Richard. Richard sent me an email and said, "Isn't the 10th a Tuesday?" And I said, "Gosh, you're right." And we got it sorted out anyway. So you will hear from me about the next meeting. It is always a pleasure to see all of your faces. As always, this will be uploaded to YouTube and onto our website. And one final reminder, Kaz has already sent me his and Heather's, but if you have links to interviews that you did with the press on Eclipse Day or any Eclipse Day, send them my way. You have my email. And we'll get them onto our website and into newsletters and stuff, and we'll send them to NASA. So thank you, everybody. Have a fabulous Monday evening. See y'all later.